Okay, so we're gonna start the Q&A portion. There was a lot of information there, certainly, and so all three of the technology providers, we're gonna do a Q&A. First, we're gonna start off on in person here, and then we'll, depending on the volume of questions, we'll go to the virtual audience and sort of work as a tag team. And I have my colleague here with me, Amy Barad, with the Massachusetts Clean Energy Center, one of our partners, as Jim Feeling had mentioned, along with the Department of Energy Resources. And we have Samantha Meserve here from the Department of Energy Resources as our state partners in our Clean Energy Results Program. So at this point, I just want to open it up to any questions from the internal folks. Again, I know there was a lot of information, but please don't be shy. Any questions? Yes, sir.
This is more for Irving's presentation. I was just kind of thinking, has this application ever been used for providing heat to a roadway for addressing snow melt or snow removal? Or any technologies related to snow removal or snow melt using wastewater recovery?
To the best of my knowledge, no, but doesn't mean it couldn't be.
Okay.
Right.
And I was just in Vermont yesterday, and we are talking to a lot of ski resorts, actually Snowmass out in Colorado as well. In addition to doing hot water production for the hotels and lodging, we're going to be doing snow melt for the sidewalks, and also, believe it or not, taking energy out of the snowmaking pits. Believe it or not, again, 40 some odd degree water still has energy in it. So we're going to actually be, in addition to making hot water and doing all the great stuff with it, we're going to be increasing the efficiency of the snowmaking machines, which they love. More than actually the hot water from the resort. Can you make our snow more efficient? So yes, the answer is yes.
Okay, we have, I'll be right with you. We're gonna have one question from the virtual audience. Amy?
I believe this question is probably most appropriate for the Piranha system, but you guys tell me if I'm wrong here. The question is, what is the approximate capital cost for a single family residential home installation? And what is the approximate ROI in terms of cost savings versus gas heating and traditional air conditioning? Can these be used in a district heat model for a whole neighborhood?
So single family home, this technology is still, I don't think we're scaling down just that small. I know you have a mini guy, and we're working on a Barracuda or some other fish name. But we're looking for a small one as well. But right now, single family home is still not there. But if you can now tie in a neighborhood, certainly we're looking at some stuff up in Ithaca, like, those green communities, they're all kind of near each other. So, but again, it's a different conversation. So I'm sorry to tell you, but single family is not.
And to the question about the ROI, so with the ability to finance, the ROI really depends on if the client wants to make a capital contribution. So if they don't want to make a capital contribution, the instant ROI,
Right.
But they can tailor it, and the thinking is any capital dollars they can put towards it, we can tailor what the ROI is, but it will also reduce their operating costs. So it's that balance. I don't know if it's like this everywhere, but for public sector in Canada, the capital budget and the operating budgets are two very separate things. So we can get some capital dollars, maybe government money or something like that, to reduce operating costs. That's one model. I can tell you for the hospital, I think the payback, simple payback, is probably around 3 or 4 years. But when I was at the hospital, we chose a very specific amount, a few $1 million, to make this capital contribution.
Yeah, from an ROI perspective, the Uric system, you're usually breaks even in 5 to 7 years.
And what I would say is that with these innovative technologies, I have found that trying to sell this type of tech on a simple ROI or simple payback is impossible. It's really about, or at least that's a really challenge. I should say it's a challenging effort. When you start stacking the value stack of the societal benefits, first of all, the tax credits, and you've got the, decarbonization, electrification, carbon tax, all that stuff. When you start tacking, and then you talk about operational savings, and yes, now it makes sense. So it's when you have clients and end users with ESG goals and larger aspirations than just simple payback, it's a much easier conversation. But again, I think to his point is the bigger the project, the easier it is to scale because you're trading, you know, a small, like as I said before, a small input of KW for a massive thermal transfer. So the bigger, the better. I don't know if you guys agree with that, but yeah.
Great, thank you. I think Kristen had her hand and then we'll go to a couple.
Thank you for your presentations. I was wondering if each of you could talk about what the delta T is, or what the temperature impact is, both from heating and cooling, and if there's any cumulative concern with the temperature change for the biological treatment process.
I'll start. Sure.
Can I just say one thing before, Saul Kinter, who's going to be speaking later today. He has actual data to show, that flood event that Aaron had mentioned. So he has some actual data, but I just wanted to mention that, Kristen, first, but go ahead, Ed, excuse me.
So I will defer to Saul when he speaks, but it is a minimal impact, maybe a 3 or 2. But central to the process, probably think everyone is working with the wastewater or the water department to make sure that there is no impact either to the infrastructure or to the processing. In the case where you're adding temperature, sometimes it's beneficial because you get more bioactivity from that, but sometimes you're removing temperature as well. But it is minimal. The larger the sewer, I know I spoke about the Toronto Western one, minimal impact, especially since this is a very large sewer in downtown Toronto. By the time it gets to the wastewater treatment plant, it's got a lot more flow added to it than the other building. So definitely something we looked at. But from, again, working with the waterworks, no concern from their part in any installation accident.
It's an excellent question and one that I handle pretty much on a weekly basis. And just to dovetail on what I was saying, so wastewater treatment plants are very, very concerned about making sure their water stays in that right temperature for their bugs. So, but there's so much flow. And we're side streaming a portion of that flow, right? So it's a fraction of that flow. And then of that fraction that we're taking, it's like a 10-degree delta T. So it's a fraction of a fraction. So it's negligible. I would say it's almost immeasurable. The data that Salt's on is more like the temperature of the water coming in as far as like environmental impact. But as far as us negatively impacting the biological treatments of the plant, the answer is no, because we go out of our way to make sure we speak with the plant. Tell us what your range is, and we'll make sure we set all of our operational parameters to stay in that range.
In the case of urine, again, you're dealing with, and it's still about 2 degrees, right? That's an average, right? 1.5 to 2 degrees. But you're dealing with such a large amount of water, as you said, and also such a large infrastructure, right? So your water's got a long ways to go before it gets to the plant. It's going to be mixing, and it's also going to be touching a lot of equipment that's already in place. So that geothermal effect kicks in. It's not been a problem.
And I will say that may it come to pass that we have so many wet installations that we have to start talking about. But it is a concern. If we sign up a big development here, we have to make sure that developer we're not going to put somebody upstream who's going to take all that energy away. So there's going to be some contractual and some codes and zoning. Trust me, that's going to be the fun. We're easy compared to zoning.
Yeah, that's one of the long-term
Yes.
challenges that we're thinking of.
So we get a lot of questions. So we're going to switch to virtual right now, and then we're going to go back with some folks in person here. So just to the panelists, if you don't mind, just try to, as much as you can. I know this is very exciting for all of us. And if there's a way to actually just we want to get to as many questions as we can in the next, let's say 8 minutes or so.
Faster this time.
If you can. I was trying to be, diplomatic, but thank you, Ed. Amy, go ahead.
Okay, we're gonna do 2 questions for Ulrich. So the first one is, what is the minimum sewer pipe size for the liner?
30 inches.
And, excuse me, second question is a little more involved. The person says they can see the system is installed via manhole cover. So does that obstruct the manhole access significantly? And also, the feed to the user must be bored or trenched from the manhole cover area to the user. Is there any sense of the cost per instance to do that, say, per 100 feet?
Okay, I don't have, I don't have good numbers on that right now for America. The trenching is relatively simple. There's no digging required on the roadway, of course. The pipes enter through the side of the manhole, so there would be like a vertical drill from the sidewalk out. The pipes would then enter into the manhole, go down to the sewer level where the therm liner is. And they really don't take up much room at all. I actually had a slide up there, but I probably went past it too quickly. But they don't impinge on the safety of the use of the manhole.
Awesome. Thank you, Frank. We're going to go to the gentleman. I think, not quite sure who was first here, but sir, you with your hand up? Could you mind standing up? Because we're trying to pick you up from this mic here, which is pretty sensitive, but.
Sure, Scotty Linder, Longwood Energy Group, and this is probably for Heber and Sharp. You were speaking of energy recovery from influent or untreated wastewater. For treatment plant applications.
Do you mind stepping up a little bit? I'm sorry. Excuse me, I just want the.
For treatment plant applications, why not use treated effluent? One of my clients actually does that already.
Absolutely. So if that ability is there and there's a treatment plant close to the source, that's exactly what we'll do. And some of the installations where we've done are looking at do exactly that. The beauty is we're able to handle raw wastewater. So if the treatment plant is far away, but there's a nice source of sewage or wastewater nearby, we can access it there. Obviously, the civil work, the infrastructure work, the further away it costs more. So yeah, you could do that. And you could also direct wastewater right from a building, industrial process. Even condensate if you're dumping, steam condensate to drain. Yeah, but you're right. Clean wastewater is nicer. It still has some things you need to be concerned about, but it's obviously it's not always accessible as easily as we'd like it to be.
And what I would say is, as a rule of thumb, we prefer the influent because it's just raw sewage and we're dealing with things that we can either drop out or chop up and pass through. The effluent, Brock Trimble, who's the real brains behind this, he's online. I don't know if he can speak to this, but the problem with the biological, we have dead bugs essentially, and they can tend to glom together and turn into amounts of jellyfish. And because we have like a plate and frame heat exchanger, they can get caught up and then end up clogging the plate and frame heat exchanger. So we prefer to deal with the influent because it's a much easier source to deal with, believe it or not. There are some applications where we're dealing with really clean effluent, where it's been so filtered down, then no problem. But we take a case by case basis. As a rule of thumb, we'd rather grab it on the in than the out. But we're Canadian, so we're nice and we try to,
Frank,
work with it.
did you have any comment on that? Okay. There was another person. Yes, sir. Do you mind?
There's a question on the Eric system. Most of the examples were I think all of them were in gravity lines. Do you have any installations where the heat exchanger is placed in a force main, like a large diameter force main?
We do. We have a special pipe that we have designed for force mains. Again, they're custom designed for the specific application, but if there's a force main need out there that meets our minimum flow requirements, then yeah, we have a solution for that.
Thank you.
One more in the audience, and I'm going to go to Amy.
Thank you,
It's
Dan
close
Root,
by.
Ty and Bond. This could be a question actually for Mr. DeBarber, but do any of you have examples of case studies that have been funded through a MassDEP grant or under other funding source? Yet, maybe in the works.
Not yet.
Not yet.
Would
This,
type of thing be eligible though? Or I guess maybe. Gap.
this is sort of the beginning of that. The first part of is really trying to educate folks about the technology, and so we have our partners. We're looking at what are some of the needs, what are some of the gaps, and so forth. And so this is ultimately we're hoping our objective is to try to road test, let's say, 4 of these pilots or demonstrations within the next first or second quarter of 2024. So more to come on that, honestly, but I'm sorry, this is the first part of, I think, an evolving and important discussion in connection with all of the folks here and to actually get a project up and running and evaluate it. That's in our project plan.
And I would just add, if I may, one of the conversations that we've been having, we're currently talking to MassDEP, how to properly incentivize this technology. If you heard me before, I think, our tech equals geothermal. It's the same thing. We're just using dirty water as opposed to clean groundwater. So personally, I would love to see wastewater energy transfer incentivized the same way that ground source heat pump retrofits, $4,500 per ton of heating and cooling offset to 150 tons. It's a lot of money. If you can come to a developer and say, listen, this incentive is available, as I'm sure everyone in this room knows, that's what really is going to move things. So we'd love to talk to anybody who's willing to help us get that incentive.
Thanks, Aaron. Next question is from the audience, virtual audience.
Yes, I think that's a good lead into this question, which is for each of you in turn. Who owns and operates the system in each case presented, or if there are options, what are those options?
Yeah, so there's the option of ownership, the property owner that's gonna buy the energy could own the system in total. Some of these systems get very large. Sometimes they don't want the risk of owning the system from an operational standpoint, in which case a financier steps in, owns the system, and then delivers energy under a PPA fashion, right? Purchase power agreement.
And I dovetail on that. So Nashville Western Center is owned by Centrio, it's ESCO. Lelum Village is owned by, and I can never pronounce the tribe's name properly, so I won't. So that's privately owned. And then we've got public-private partnership in the Falls Creek, and that's a standalone utility. So any financing model, and one of the things, and I know, trying to keep it quick, there's a lot of third-party, money out there, green capital, waiting for the market signals for them to come in, and they want to basically, much to what was Evan talking about, come in, to go to a municipality that's strapped on cash. We'll buy the whole project from design, implementation, operation, and you just basically pay what amounts to your utility bill for 25 years and get the service right off the bat. So very flexible financing options.
So just to add, I mean, it could go everything from selling the equipment and maybe supporting with a service contract to, partnerships, co-ownerships, working with municipalities or tribes and things like that. So very, very flexible.
Thank you. Another question there?
Sure.
We're supposed to go to break at 10:30. I'm gonna throw an item out real quick. So we've got a panel discussion after with these folks and some of the other folks that are presented from that perspective, but I'd like to go a couple more minutes and just get through a couple more questions. And some of these other questions maybe we can get to as part of the panel discussion, because we do have over an hour and 15 minutes, and we're going to have just a couple of brief presentations and then opening remarks for the other panelists to join in, and the tech providers will be here as well. So let's take a question from the virtual, and then there's an audience question too. We'll go to that. Go ahead, Amy.
Okay, we have a technical question for the Shark system. Computer requires a restart.
Just exit. That's a state function. Don't worry about it.
Okay, so with respect to the plate and frame heat exchanger,
Yes.
you mentioned that sludge is pumped into the heat exchanger. The viewer wants to know how you prevent plugging and biofouling of the heat exchanger, if that is the case. If that wasn't the case, is there an intermediate heat exchanger prior to the plate and frame? And there's a follow-up on this too.
So the way we keep it is scrubbing velocity. So the Shark has a minimum flow of 100 gallons per minute. So the trick is, again, we get those suspended solid 3 millimeters in size. The plate and frame heat exchanger has a gap of 8 millimeters. So by keeping that scrubbing velocity up, we can move that wastewater sludge through the heat exchanger and do the thermal transfer and not have anything fall out. And there are cleaning in place procedures, but knock wood, we've never had to open up a heat exchanger in the 13 years of operation. So long as you design it and let us operate it properly, we're good to go.
Well, the follow-up question was about maintenance, the maintenance process, and what would that
So
be in the?
Piranha is usually once or twice a year, depending on usage. The Shark can be quarterly, depending on, again, the amount of usage, but during the warranty period, we say, do it 4 times a year, and then after you kind of get through that, we might be able to back it down to twice a year, but that's all handled through market partners, or if you want to have it, there's all kinds of ways to set up the service contract, but the real key is proper design, and we won't have biofouling. I'm pretty sure you guys have the same concept. And
Okay, Michael, do you want to step up here closer, if you don't mind? And we'll take a break shortly, but just everyone back at, not yet, but Mike, go ahead. You got the floor, Mr.
Thank you, Mike. Thanks for your presentations, guys. A quick question, just to tease out the geothermal comparison a little bit.
Mhm.
What if a sewer is not running 24/7? So geothermal is always there, the ground's always there, the groundwater is always there. You go into Boston, most of the time the sewers will be running 24/7, but if you go out to the smaller municipalities, maybe out in Western Mass or Metro West, they may not be running 24/7. If you do have a building that requires heating and cooling in the evening, just for the three of you, what is your approach if you don't have a sewer that's running 24/7?
who would like to start? There you go.
So great question. So we can combine, and I'm sure it's the same for the others, but we can combine with other technologies. So thermal storage for one. So, capture the heat when it's available and thermal storage. We can also combine with geo. So we can mix and match and really use the Hoover technology as either a base load or peak load or whatever. The other is air source heat pump, whatever there's available. But most common, what we typically like to do is put in thermal storage, which can also be used for resiliency, redundancy, and also for those, as a buffer, if you will, even out when there's not the appropriate flow. The supply and demand of heat is not matching up exactly.
And you nailed the word, buffer. So our systems, generally speaking, always have a wastewater holding tank to buffer against low flow periods. So there's a lot of math and a lot of analysis that goes into the design system beforehand. So it very well come to pass that small municipality, wastewater may not be the optimal primary source, but maybe it's geo, or maybe it's, a mix of other renewable assets, but that tank is really the key for us. Especially for the piranha, because in a state where deregulated electricity, we like to capture that in the evening flow. Everybody comes home from work, capture all that wastewater in the tank, make hot water overnight when electricity is cheaper. And then when you wake up in the morning, take a hot shower with water made from the wastewater you made the night before. So that tank is really the key for us. And also, again, like I said, allows us to qualify for the investment tax credit because now we have a thermal storage component of our technology. You're good.
I live by the rule that you can't be all things to all people, right? So we focus on applications where we do have access to flow 24/7. For us to achieve our goal, which is to displace, the massive amounts of carbon we're generating using fossil fuels, there's a multifaceted approach that we have to take, right? So we're not the answer in every case, right? In many cases, we're not the answer, especially out in the outlying municipalities that are smaller and don't have really large pipes and really large flow rates, right? There might be some place in that municipality, which you'll hear later on during the discussion, where you can take advantage of our technology, where they do have constant flow. But for the most part, when you're out in the villages and the communities, there's a lot of applications where urine just isn't applicable.
Great. Thank you. We're gonna take a break till 10:45. If everyone can promise to be seated, ready to go by 10:45. We have an hour and 10 minutes. We're gonna have the technology providers and folks on the virtual audience time to get your second cup of coffee. And we're also gonna have the other panelists that are gonna be on here. We'll get them set up so they're ready to go. So 10:45 back here, and we're gonna start in. Thank you.